again. My name is Olena. I actually arrived here from Berlin. I love Warsaw. You have the most amazing food ever. So I work for Confluent, and normally we do a lot of serious stuff like banking transactions and all that stuff with data streaming, data processing, then storing the data, analytics. But today I wanted to talk about something which is a bit on the edge case of something a bit more modern, like using a bit of AI together with all the data we collect. So the business use case will look as following. So we are not going to focus on us. Actually, how many developers we have in the room? Okay, how many non-developers are here? Some people didn't raise hand for other of those questions. Anyway, majority of here, I guess, developers. Those who didn't identify with any of the groups also are very welcome. But the need for the business, or for business idea, actually, I wanted to talk about, comes from our management, kind of the boss. And the boss wants to be smart, and during some conversations with their stakeholders, and that's actually a real use case. I'm kind of describing all these cats, but the thing is actually applicable for people as well, and actually is being used in real life. So during the, for example, conversations with stakeholders or some other meeting where they really need to have latest data aggregated and meaningful response, they can ask some kind of question. For example, here, show month by month fee income from May through September for our Central European branches, only the teams whose performance improved by at least 5%. So a bunch of things here in the request coming. And technically, very important people from analytics team. Do we have people actually who works here with SQL, do some smart analytics? Only one person. I'm really sad for you, and please don't be very judgmental for whatever I will be sharing. You can share later all the feedback with me privately, please. So yes, but anyway, for those of us who actually are not really good with analytics, we also sometimes want to ask those questions and get some really fast response. And we can actually use some kind of a helper, an agent, and we are talking about AI today. So some kind of LLM which will be able to gather information which comes from some sources with maybe like real-time data when people are, cats, here is cats, buying some stuff. The data is probably aggregated as part of events, then stored in some kind of a storage. And technically we can access the data through that agent, which will be able to translate natural language, whatever we or our boss asked, use some extra queries to determine the query, the schema of the database, write some SQL requests, and then return the response back to get that valuable information for the person who asked a question. And this is the whole idea which I wanted to discuss today. So how we can use the latest advancements in AI and machine learning to be able to get information, analytical responses from the databases which we have without actually writing manually SQL responses, to save the time and also allow this to those parties who are not super eager to write SQL and kind of deal with all the amount of data we have. We are going to use some technology on top of it. As I mentioned, I'm coming from Confluent, so this is the original co-creators of Apache Kafka, the founders of the Confluent. And we are going to use Kafka to stream the real-time data for the demo. Then we are going to use also Iceberg to store where we are going to store the data. We are going to use MCP, which relies on Trino. So this is more or less kind of an overview, just in case you realize there is another more interesting talk outside. I will not judge. But this is kind of what we are going to cover today. And the demo looks like this. So the whole idea, what more or less we want to achieve. This is using Claude and more or less asking some question. I have some data from Bitcoin. So kind of a question about the value for drawdown of Bitcoin price today. And then MCP will help Claude LLM to figure out all necessary components to answer that question. It will actually will try to list the catalogs and schemas for the table. Will run into some errors. For example, here, some mismatch input, so it didn't work from the first time. LLM can retrigger that and get something which actually works. So get the schema from a table flow. I will explain more about technology later. And what actually brings kind of all the necessary data for it to retrieve. Then trying to get more requests, like to describe table flow, and getting that as well. And step by step, trying to analyze the structure of the data and even like getting, for example, 20 first items in that table so that we are not retrieving the whole value because it will be quite inoptimal, but just kind of getting how much data we have. So what is like, for example, here we have 1 minute interval. I'm streaming that from some open APIs for the cryptocurrency. So I have this data coming on 1 minute interval. So it discovered that. It actually discovered there are more than one table, and like one of the tables has better structure to retrieve the data. So it understands a bit the data, and finally writes then the SQL query to answer the question which I asked, and retrieves the information which I need. As if I'm super interested in cryptocurrency, but assuming I am. And then I get that data. So this is more or less the flow. It's kind of nice in isolation as a demo, but there is a lot of challenges there. And actually, I wanted also to talk about those challenges and how exactly, to which extent we actually can use LLM as an analyst. So those of you who actually aimed at the job of analyst after you stop working as a developer, like it gives you an idea if actually you should go there or soon analysts will be also replaced. So they probably will not be replaced, at least not all of them. So let's talk about the first part of this. So generally, natural language to SQL. This is actually probably the biggest, not exactly bottleneck, but the thing which actually either make the whole system work or bring really wrong results and you will not even notice. Because LLM can really improvise, and when it comes to analytics and like real data, that improvisation really kind of sucks. So here on LLM, when we are using LLM, we are relying that it will give us a couple of it can do translation of real language to SQL, then figuring out the schema, and also writing the select queries. So those three things we need from LLM. And the progression of how it works over time and actually why this is actually right now pretty promising. We, like back in 2004, we still were using like kind of rule-based systems, which were trying to translate natural language to LLM. It was working in very, very limited context. Right now we are in LLM era, and this is what we are focusing on. And there are a bunch of benchmarks, which actually you can later, I will leave the links later, check. each of those benchmarks makes like things more complicated for the LLMs. So with WikiSQL, it was pretty easy tasks for LLM to translate natural language to SQL. And then right now, like after Spider, CoSQL, BERT right now actually introduce more complex requests which needs to be translated to SQL, and then it's possible to use that benchmark to validate. And actually also like historically, if we look how the first systems were translating, for example, here we had SQL to sequence to SQL, a deep neural network from 2017. It was doing pretty well on the WikiSQL benchmark, but then when it was measured to the Spider, it was falling down. Then we had other neural networks which improved. So it's kind of like every time we introduce a new LLM, or like a new some kind of AI mechanism, so LLMs right now, we can see that the performance improves, for example, for Spider, right? But then we introduce a new benchmark, BERT, and now all those, like GPT-4 is not doing as well on BERT as it was doing on Spider because the benchmarks becoming more and more complex. And we aim actually to use more complex benchmarks because they represent more like real world scenarios. So this is the BERT one. It actually uses the ranking for different models, as well as you can see how real humans compare to those LLMs. So here, for example, humans can solve almost 93% of the tests. And at the moment I was taking this screenshot, the best model was doing 77. So it's not exactly that bad, but also it's not perfect. But also the thing is improving over the years. Over last 5 years, we improved significantly, so we can really see that probably, like, let's say another 5-10 years, we will be there to replace all the analysts in the world. Probably not. So anyway, for all those benchmarks, I believe the links you can check in more details because they have a lot of interesting stuff there, how exactly they solve it, all the related papers, a lot of those models or solutions which actually use LLMs to translate natural language to SQL also have related papers. It's kind of a common thing to write a paper when you do something right now. So anyway, so it's pretty cool. So, and in general, then what LLM does, it tries, when it is being trained, it learns the patterns of SQL and natural language. And then it can kind of detect dependencies. Though it doesn't really do any like real reasoning, but it can still detect dependencies. And for example, if it says like from Germany, it can translate it to where country is like equal to Germany. It also, LLMs know that they need schemas. So when it starts working, when I ask a question, it can actually make those clarifying requests to get the schema, get a chunk of data. Good LLM will know that actually it shouldn't retrieve like all the values. So do not write queries which are inefficient. By the way, the latest benchmarks also evaluate by the efficiency of the SQL query, because inefficient SQL query is kind of dangerous. However, there are a number of challenges still. For example, if the data set is big, ambiguity, or like using, what do we mean? Which table should be used? When we are describing something in the natural language, it can mean multiple things in the SQL. Complex nested queries, again, this is what is measured in the latest benchmarks. So the more complex stuff is still difficult to large language models. Joins are also pretty tough. Schema complexity relates also to the complex queries. So a lot of different things which still needs to be improved. But again, this is where gradually, year by year, we are doing better and better. And every model is like with those benchmarks for LLMs, we are really like doing better. So this is more or less on the LLM side. Another things, they are more a bit, I think, more stable and they work pretty well. But let's talk about model context protocol. This is something we actually need to give LLM an access to our database, whatever database you have. How many of you here used MCP before? Oh, cool. We have plenty of hands and also people who never tried it. It's pretty cool mechanism and lately very common for people use MCP. So yeah, so MCP is more or less, just in short, you can think, or this is how they describe themselves. It's kind of like USB-C port. So it's in a way to connect whatever interface you have or the IDE or whatever system you have, and you can connect it with some source of context. So when you can retrieve additional context using LLM, it can be accessed actually to the web site, or it can be just data from the database. All those things can be used by LLM to make like better, to give you a better response. And in general, we have several participants. We have MCP client, or we have actually MCP host. For example, it can be Claude. Then we have MCP client, kind of an instance which will use MCP, and then MCP server, which can be, for example, a file system on your computer or somewhere else. Or in our case, we will be using data storage. Then when we come to layers, we have transport layer. Today it's not super it's not super important for us. Data layer is a bit more relevant. And here actually like MCP, when you have your MCP server, you will have to take care about that data layer. And in general, we have multiple tools we can use. So MCP, you can write your own MCP and make it as complex as you need. But we are going to use MCP for Trino, and I will explain later for Trino. There are a number of MCP, and there is a website, or like websites, if you go to MCP documentation, which MCPs you can use. There are so many of them. You should be careful. You should not trust any MCP because some of them cannot do a lot of harm, but the one which actually will require, for example, keys to access your data, or some other, like, for example, file system, you should try to give it as little space which is needed to perform that operation, and not give a lot of freedom because you don't really know people probably who wrote that MCP server, and you should really be a bit more careful about what exactly is being done with the access given. So I will leave, not to spend a lot of time on the implementation of the demo, I will leave a couple of links at the end. But generally for this MCP, this is actually, by the way, how the configuration works. Here I have MCP Trino. The command here is the actual executable, which I got from my MCP server. And for my Trino, it was collocated on the same machine where MCP was. So here I actually go to localhost, and it provides like information, and even like this very ugly Trino scheme HTTP, which is not super secure, but it was localhost. I think I should change it to HTTPS in the future. So here, for example, if you do it in Claude, you can also tell which of the tools can be used by your MCP. If you want to be more cautious, you should disable some of those. So that's MCP. Then for real-time data, whatever data when you're calling Uber, or you're using your smart home, or you're paying something with a credit card, that data usually we want to get as fast as possible and to react to it as fast as possible. For real-time data, we very often use Apache Kafka, probably one of the most well-known open source systems for data streaming. How many of you are familiar with Apache Kafka? Okay, we have probably good percentage of 0. For those of you who are not familiar, Apache Kafka is designed to navigate the data very quickly from one point, one system to another system. Can be microservices, can be your systems within a bigger platform. It has a kind of producers, so those systems which, for example, create the data and send the data. Then we send the data to what we call a topic. I heard this comparison recently. It's kind of a post office. In a way, you can send the data, so you decouple the person who sends the data and then the entity which then needs to read the data. So you send the data as a producer, the data is stored in topic, and then consumers can read the data when they need it. The only important part was those of you who never used Kafka, but for example used queues. In Kafka, we don't remove the data which is read. So if consumers consume the data still stays in the topic. So you actually can consume the same data again and again and again whenever you need it. There are limitations, but that's for a different story. So that's Kafka, and the real time we send to Apache Kafka. Now from there we can, so actually here I also used for the real time Kafka Connect, and here the data comes from the CoinGecko, kind of an API which gets the data about the cryptocurrency. It's one of the kind of advantages of using Apache Kafka is that we can create multiple connectors to bring the data from some kind of a source. And here is just some external API with some parameters, and I'm getting the data on a minute basis. So this is how actually it looks, the data which we are asking later with MCP. It has different coins and then the values for those coins. I also then clean it up with Apache Flink a bit and disaggregate it like kind of in a more focused chunks. That's where the MCP checked what kind of tables I have and realized that one table has a bit more granular data per each coin, so it's kind of a bit more easier to use. So we have the data, and then we store the data in a data lakehouse where we can retrieve. So we have the concept of data warehouse, and we have the concept of data lake, and those have each of which have pretty good pros and cons when using it. Here I'm using actually a data lake house where we are working with data lake. So all the files are stored in a data lake, but we have kind of this meta data layer on top of it to imitate a data warehouse. And I'm using Iceberg for this Apache Iceberg technology. Any one of you have used Apache Iceberg? We have various, okay, two hands. Two hands, okay, good. So Apache Iceberg is it's actually like a storage, is an open table format which dictates how storage should be built. So it's an open standard which actually is designed to unite a lot of different players on the market, so that AWS, Snowflake, Databricks, they're all using that storage, and it's kind of, they are working on that technology which is kind of neutral to any of those parties. Apache Iceberg is the storage, and here I'm using also the technology Tableflow, which we have at Confluent, to move the data from Kafka to Apache Iceberg. But what we also need, we need a query engine. So Apache Iceberg is a storage, and for the engine, we can use multiple different technologies, Spark, Flink, Trino, DuckDB, so they all can read from Apache Iceberg. which actually makes Apache Iceberg pretty convenient tool. I'm going to use Trino. Actually, no strong preference of any of those technologies. All of them amazing. DuckDB is pretty cool. But here I'm going to use Trino just to give you an idea how exactly it works. For the Trino, I have to provide more or less where the catalog is located and what are the keys to access the catalog, like that. This is the credentials. Trino then will have its own address. This is actually from MCP. So I will then give MCP information about the Trino. And Trino, as a query engine, will be able to make those requests from the MCP side. So, so this is more or less how it works. So whatever like data storage you have, you need a way to make the requests to there. You use an MCP for that particular technology. Again, validate that you are not providing some keys for some random MCP written by the guys who really want to access to your sensitive data. But apart from that, it's pretty solid approach to connect LLM to whatever data source of information you have. Of course, for evaluation, we can evaluate our system. We can actually, if you plan to use it, you have to think about a way how exactly you will create some kind of a suite of the questions and also SQL, which you expect to be translated by LLM, and also run it on some kind of regular interval, so that if you are making some changes, you understand if you have some regressions in your mechanism. Then also for the security, it's quite important. Think about MCP tools as another API endpoint and don't give it all access in the world. So try to do it per role restrictions. So kind of try to actually limit as much as possible what you give to the MCP. And even those different permissions you can limit in the interface or whatever you're using different tools. So, and then for the adoption, I would recommend to start, if you decide to use this approach in your system, you can. I think that it actually works pretty well. But start with a curated data set so that you have a more controllable environment. And kind of like here, so that LLM doesn't do anything stupid, always make sure that you have read-only database user. Try to use limits, for example, not to retrieve the whole data set, but kind of set it to something less. And then see how it works and maybe like to grow it. Then with MCP tools, also like try to do it with less of the MCP tools so you can control them better. Also track exactly what exactly is being executed so that you have kind of this history and you can analyze. Evaluation, as I mentioned before, and also so that, for example, like we had it in the cloud, whenever you see that LLM does some conversion of natural language to the SQL, so that you can always see what is happening. So you don't have this black box that LLM does something. Because LLM is really good at lying, or like not lying, but kind of generating rubbish, and you want to catch if that is happening. And again, better to catch it with some tests. So that's it from me. I have a couple of links. The first one has the link to more or less like demo and all different materials. And the second one, for those of you who are Kafka people, and if you want to have some fun way to evaluate your knowledge, try out this certification. It's kind of fun. Can be done in like 15 minutes. Actually, yeah, you can do it even faster. Like I know people who did it shorter. That's it. Thank you so much for joining this talk.